After you've used your drill batteries for a while, a lot of times you'll start to feel like they kind of give out too quick. So this one got labeled weak. You'll notice that when you charge them, the charger will say it's done, but yet it won't go all the way up to 4 lights. It won't show that it's full. Generally, that's because every 18-volt pack is made up of 5 sets of cells that are in series, and each of those sets is supposed to be about 4 volts times 5 is about 20 volts. And if one of those sets of cells gets out of sync with the others, it gets discharged a little more, then the battery won't be able to charge all the way up, and it won't be able to draw all the way down because they're out of sync. So what you got to do is you got to take this apart, and you have to hook up a balancing charger to it. There's a lot of different ways to balance out the cells, but essentially what you're trying to do is just to make all 5 sets the same voltage, and then you can put it back on your regular charger, and it'll start working fine. So to take this Milwaukee one apart, you need a T10 security bit. It's got the little hole in the middle. There you go. So it's a 6-pointed Torx bit, size 10, with a hole in the middle for the security type. And these have 4 screws that matter. There's other screws sometimes that don't matter, but these have 4 screws that matter. Once you got those out, then the top will come straight off. There's no latches or anything. I label these. So this is an 8 amp hour. I label these 8 so I'll remember which is which when I'm trying to put them back together. I'll go ahead and peel that off. So when we're done, hopefully it's not going to be weak anymore. Before you start to measure the voltages on the Milwaukee battery anyway, these nickel plates have like a plastic coating over them. Get in real close there so you can see that. So you have to scrape that off before you can actually make a voltage measurement. So once you've scraped that off, then you can make voltage measurements between the different there's 1, 2, 3, 4, 5, 6 different terminals that you need to scrape. Because you've got 5 batteries, and then you need the pack negative too. So just come in here and scrape these enough, because ultimately we're going to be soldering on the wires to connect up the balancing charger to get them back to spec. These big ones here, if you go near the edge, it's a little easier to solder onto them because they're such a big piece of metal that it kind of acts like a heat sink, and you'll have a little hard time getting the solder to stick in the middle. And you want to make sure you don't short out. There's like a piece of metal right under there. You don't want to short anything out from metal to metal. It's low voltage. You're not going to hurt yourself by electrocution, but if you bridge any of these different contacts with metal, you'll get quite a large spark, because lithium batteries can put out a ton of power, a ton of amps. So if you bridge metal to metal with metal, and you've just put a load onto that battery with very little resistance, which creates a huge amount of amps. Look up Ohm's law. Okay. So now the terminals are clean. We can make our voltage measurements, and now we're also prepped to solder on. Now, so I've got a voltmeter here. I've got it on volts, and we want to make sure it's on DC volts. So DC volts. So we can see the voltmeter at the same time as the batteries. On this battery, they're labeled in here. This one is battery minus, and this one's battery plus. They're labeled down on the circuit board. It's hard to see with the camera, but from minus to plus, the whole pack's voltage in total, with all 5 series sets of cells, is 19.64 volts total. But what you'll find is, so now this one happens to be the pack plus, and this one's the pack minus. So we should get the same 19.64 volts. Now, since if we did it backwards, you would just see that it would say it was negative 19 volts. That just, negative just means we've got it backwards. It's backwards of what we've got. Red is usually positive and black is negative. So we're going to put our black here, and this is the pack negative. This is the first set of cells going across. There's 2 cells, I believe. I think this one's 2. There's 2 cells in parallel, and that's the first series set of cells, 3.50 volts. And now there's no need to flip the probes around. We can, since we're already probed on this one, which is, this is the plus of set 1. It's also the minus of set 2. You can see that there's a little metal strip that connects these 2 rows of batteries together. So this is the minus of set number 2. And if we go from here to here, we'll see that it's negative 4.14 volts. It's because we're measuring it backwards. It doesn't really matter, but you can see the first one is 3.5, this one's 4.1. That's way out of balance. And so we got to get that fixed. So that is the problem right there. But there's typically, with hard use, a lot of the cells get out of balance, and just something you're going to have to do. If you want these batteries to last a long time, you're just going to have to pull these apart and balance them every once in a while. 3.7. So that one's different than all the other ones. This one's 4.15. So this set 4, is the same as set 2. They are balanced to each other. So that's good, but you still got two other ones that aren't balanced to anything. And then set 5, 4.14. So that's very close too. So we have 3 that are all balanced together pretty well, and then we have two sets that are low. And that's why the pack isn't charging up all the way, and that's why the pack is not discharging all the way. So we want to start our soldering iron heating up, and while that's heating up, we got our solder here, the kind with rosin, helps it to flow and stick to the wire better. So while that's heating up, we want to prep the connector that we're going to solder. We're going to solder onto these points. We want to prep this connector. The chargers, the balancing port on the lithium, like RC type chargers, that LiPo chargers, but we can set them to lithium ion. They have the male side. So here's the female side of the connector. We want the female to plug into the charger, so we're going to cut off the male side. But it already has these handy dandy pins in there, and those are real nice for soldering onto the battery. There's not a real good way to just like clip alligator clips to the battery. It's just so tight with all the little metal strips. It's just too tight. So what I do is I come in here and I just kind of, with some thin wire strippers, I just kind of cut into the plastic enough to dislodge and pull out the connector. So you can see now we've got a really nice hard pin that we can use to solder with. So we're just going to go through and try not to cut them off. We're just going to cut them enough to pull them out. It's kind of tricky. Here we go. You do have to cut. You can't just pull them out. You do have to cut them a little bit before you pull them out. They just won't come. Okay, so now we've got all of them ready to go. The way these, the standard for how these are to be connected is, obviously the red is the pack positive, so that's the positive side of battery number 5. So the red one is going to go here on the battery plus. And then then we just go down from there. So this is battery 5 plus, this is battery 4 plus, 3 plus, 2 plus, 1 plus, and then pack minus. So pack positive and pack minus are on the opposite sides of the pack. The easiest way to stick these wires onto these pads for me is to go ahead and, I like to go ahead and lay down a little bit of solder. So I'm going to try to heat this up. Obviously, you're working with lithium-ion batteries. They can explode if you heat them up too much. We're not heating the battery directly. We're just heating the pad. So I want to get this pad kind of hot so that the solder will bond to it, and lay down a little film of solder. And, you know, that's enough to make it really easy when we come back, to make it easy to stick on the wire. So we're going to put this flat against the pad as possible and run a little bit of solder. And like I said, if you go near the edge on these big ones, it's going to work better. And you generally, to solder, you want to heat up the metal, and then you want to come in with the solder. Otherwise, the solder will bead up on the metal, and it won't attach. We want to get a good electrical connection. All right, now that we've got a little bit of solder laid down, we can come back in with the connectors. So again, the way that you tell on your particular, this process works for any battery pack, but you obviously have to figure out exactly how your particular pack is set up. So again, if we put the biggest pad and the other biggest pad, and if it says we have positive, close to 20 volts, then we've got negative and positive. If we had them swapped, it would say we had negative almost 20 volts, and it's in the shadow. I don't know if you can see that. It's kind of in the shadow on the edge there, but the negative sign right there. So wherever the negative is, you can start from there, or you can start from the positive. I like starting from the positive. I'm just going to go ahead and label these just so we can. So this is the pack positive, or it's the plus for battery 5. Then the minus for battery 5 is the opposite side, but that's also the plus for 4. So I'm going to write a little 4. Man, this is tiny. Little 4. So then the minus of 4 is the same as the plus of 3. So there we label that 3, and then so that would be 2, which would make this 1. And then the opposite side of 1 is the pack minus. And that looks like a 1, so I'm going to put that in parentheses. So pack minus, plus 1, plus 2, plus 3, plus 4, plus 5. So I'm going to start with plus 5. And we just you might want to take a little bit of solder. I'm going to get a little extra solder on the soldering iron to make it easier to stick. All right, so we're going to put a little bit of extra solder. If this tip gets dirty while you're doing this, you just need like a damp paper towel. You can just kind of wipe it off. I'm going to do it with a dry paper towel. You got to be careful not to burn it, but you wipe it off. Put a little extra solder on there and wipe it off. And I'm going to put a little extra. And I'm going to start with cell number 5. And we want to get we just want to get this stuck on there. It doesn't carry a whole bunch of current. It carries, maybe an amp max. So get in real close. So that's 5 plus is where my red wire goes. And this is specifically a 5S. They call it 5S balancing connector, which has 6 pins. You got 5 cells positive, and you got the minus. This is a 5S balancing connector. And all of the 18 volt batteries are 5 series. That's what the S stands for. 5 sets of cells in series. The smaller amp hour batteries have only a single cell for each set. So you have 5 total cells. The larger batteries like this will have 2 per set for a total of 10, or even for the 12 amps, 3 per set for a total of 15. All right, so the first one was 5 positive. The next one is 4 positive. So I'm gonna come in here and heat heat this solder up. Come over so that you don't, yeah, put the, heat this up and get it in there while it's hot, and heat it up some more and get it set down in there, and then it'll freeze almost instantly. This next one is 3. Next one is 2. Next one is the positive for cell number 1. Gotta get a little more solder on that one because it's really nicely spread out. Okay, that'll work. And then the minus, the last connector is, last conductor is the minus for the whole pack. Okay. Let me take some close-up videos of that. Where's my macro? Come on, macro. Okay, here's some close-ups. What that looks like. We're just trying to get these stuck on there because you're just going to have to unstick them as soon as it finishes. So here's one example of a balancing charger for lithium battery packs. This is just a branded version of the SkyMax B6 AC version 2. And not in love with this one. It's very slow for the balancing charge. This particular 12 amp hour battery has been going for like a day plus. I think I'm on the 3rd day of actually monkeying around with it with the different safety timers and everything. But I wanted to get one that had a faster charge setup, so I'll show you that one in a second. But all of the balancing chargers, you have to have the main charge output hooked up to your main pack negative and positive. So I kind of just clipped the alligator clips in there. Remember, don't short them out. And then the wires that we soldered on for the balancing connector, this one I had to extend it, and you plug it into whatever the 5S, see the 5 cells, the 5S port. And that's how you connect it to a balancing charger. Then you just put it into balancing mode. So you can see this one's, it's got 4 out of 5 balanced. The other one says 0 because there is no other cell, but the 4 out of 5 are, you know, the same. So it's working on bringing those up and keeping this one at 4.1, which is kind of the target end voltage for each set of cells. So once they all get to 4.10, then it'll be done and it'll shut off. So that's our goal. Now the new charger that we picked up to do this procedure faster is this IMARS D300 by Gens Ace. And same idea. This one has, you know, multi-use balancing ports from 2S through 6S, and then you have the output, the main charging output, and then you have another whole set, so it's a double charger. Right here, hang on to that. So we are going to get this connected to the battery positive, and this one connected to the battery pack minus. And then I'm going to go ahead and I'm going to plug in. We're going to go all the way to the left. We're going to start off all the way at the left with the positive to the right. And then we're going to loop this around. All right, so we got that plugged into channel A and the balancing port for channel A. So when we've when we get that plugged in, we can hit this button to show the current status. And these should basically be what we had measured before. So this shows the fact that 3 of them are about the same, 2 of them are out of balance. And so we're ready to go to balance this. So I'm going to hit, I believe, this button and kind of confirm the settings. So we're in balance mode. The difference between balance mode and charge mode on most of these chargers is simply that a balance mode will actually, if you set the target voltage lower than the highest cell, it'll actually draw the high cells down. It'll discharge them a little to make them hit the target, and it'll charge the other cells. So that's what balance charging is. You could go to regular charging too, and these chargers still balance while they're charging. But regular charging just tries to bring everything up now, and it won't bring any high cells down. So if you set it to the 4.1, then it shouldn't really make any difference. But I'd rather put it on balance mode. We've got to make sure that the battery type is lithium ion. For these, pretty much all of the battery packs in DeWalt and Milwaukee and Makita and Rigid and all those are lithium ion cells inside. And if you don't know, it's pretty important that you get the right thing. You can look it up online. We have five sets of cells in series, and the target current really doesn't matter a ton, but a good rule of thumb would be to make this is an 8 amp hour battery, and a good rule of thumb would be to just pick the target input current to the same as what your battery's rated for. So now we're ready to go. We're going to start. And now it's going. It's saying that basically it's 67% balanced, and it's going to start kind of doing an algorithm of charging this and drawing down that, and basically figure out the best way to charge all these up to the same voltage. And we'll just let that keep going until it's done. Okay, now I've got another battery plugged into channel B. I'm going to set up channel B. I'm pressing the left button here. That's channel A. That's what's going on with channel A. It says, and then we've got channel B. So for this battery, three of the cells are fairly close. Those other 2 are off a bit. So we're going to go enter on the right into channel B, and we are going to confirm everything looks okay. And the cell voltage here, it just kind of picks a recommended voltage based on the other cells. For the other cells, I think they were around just under 4.05, so it's okay, we're going to hold those steady and bring the other ones up to that. If we want this to be charged to 100%, then we could shoot for 4.1, and then it'll bring all the cells up to 4.1. So we'll go ahead and try that. Go down, and then we're going to hit enter on start, and it's going. The current, the current that the total current it's charging with is a little bit higher because it's going to try to bring the 3 cells, all of the cells up a bit. So it's starting off with a bang, but that current is going to drop down a fair bit when the high cells get closer to being okay. Now it's like, why do you need to do this? It's just because the normal charger, it charges them all as if they were one battery cell. So it puts a certain amount of current through plus and minus, and it brings the entire pack up to a certain point. When certain cells get too high, then it's going to cut off the charge. So when they get to 4.1, 4.2, it's going to cut the charge off, and then it's going to stop, regardless of where the other ones are. This board, has some battery management built into it. but it just doesn't work quickly enough for it to be effective in keeping the cells balanced. So like your normal charger, when it's done and it's solid green, I don't think it continues to balance the cells out. Well, if you leave it there for a long time, I don't actually know. I've never heard anyone say that. It seems like it doesn't, because I've had cells sit on there for quite a long time and they never get balanced. So I've heard people say that basically the only balancing that occurs with the Milwaukee built-in BMS battery management system, the only balancing that occurs is actually happening while it's physically charging. If you charge them on a slow charger, I think this one's a regular slow charger. This is like the double speed rapid charger, and this is the like quadruple speed supercharger. But if you charge like your big batteries on a slow charger, then it'll have more time to keep them balanced. You're stressing the cells out a little less, which keeps them a little bit more balanced. But they're still going to get imbalanced through hard use, you know, in high wattage tools like the blower, like a big hammer drill, you know. When you're using them hard, that you're going to put stress on the cells. So it's just something that the board that's built into these things tries to manage those and keep each set of cells the same voltage, but it just doesn't do a good enough job. It definitely doesn't do anything while the batteries are just sitting there idle. So, you know, something like this seems to be the most straightforward way to get these things back in balance. And that's just a normal thing you have to do with series configured battery packs. You got to keep them to where all the voltages are the same. If they're not the same, then you're not going to be getting full power out of your battery. It's going to give out too soon, and it's not going to charge up enough. So you're only using like the middle part of your cells, your battery's full capacity. So this is just something when you get to a point where you're pushing the button and it's only, you know, it says it's fully charged, but yet only 3 or only 2 are coming up, then it's time to balance it. Now there's other things that could go wrong. Those little tack spot welds, those little 2 dimples right there, those little spot welds are what holds that metal part to that metal part. If you drop your battery pack, that one can break, that one can break free. So if that's more of like you're noticing that sometimes you got full power and sometimes you have like nothing, or it cuts out really, really quick, but then it still says you've got 3, you know, 3 still. So if you're cutting out on you, but it still says you have a decent charge, then you probably have a problem here or here. If either one of these breaks loose, then that'll interrupt the whole thing when it gets a little bit warm. It'll get real hot and it'll kind of fold up while you're using it, and then it'll cut out, and then it'll cool down, and it'll make contact again. You can keep going, but then it'll cut out quick. So that's another thing to look for. It's not real easy to get these put back together. You got to do it with a little spot welder that's designed for this. You can try soldering it, but solder's not very strong. But yeah, that's one thing you could try if you didn't have a spot welder, tack welder, whatever you call it. And then you can also have, you know, the batteries, the cells themselves are spot welded. I don't know if you can even see that. The cells themselves are spot welded, and if enough of those break off, you can have, you know, weird capacity problems too. Those don't break as much. It's mainly that one right there on the battery minus, or that one right there on the battery plus that would break if you dropped it hard enough. So, and then, you know, I mean, if you, the Milwaukee Cells are pretty tough in terms of they're not gonna just go bad. Like one of the cells isn't just gonna go bad typically, but that's something that can happen too. And then as you use it more and more, the chemistry in the battery starts to get run down to where you're not going to have as much capacity. But anyways, this is a normal thing that everyone should be doing to their battery packs if they want them to last. The other thing is just to just buy new ones, but these things are expensive. So this charger, you can get this charger for about 30-40 bucks, brand new. These cables are like $5 for a big pack of them. These little guys came with this charger, and I just had to cut them apart so I could plug them in like this. But you can just use the flat, spade terminals and crimp them onto the end of a wire instead of having to do this kind of thing. So that's pretty hokey. So this one runs about 110 bucks on Amazon. But there's a number of them that are all suitable for doing what we're doing, and we'll give you a couple links for some options. Good luck. Another point of discussion is this is definitely not an ideal setup for doing crazy tinkering with lithium batteries. If something goes horribly wrong, lithiums are explosively, combustible. So it's a good idea to always keep these under visual supervision. And don't ever leave these unattended. Just going to say that. You should be sitting out here watching this for 12 hours until this finishes. And don't fall asleep. Otherwise, don't blame me if your house burns down. So don't put it on a wooden workbench. And keep them away from combustible material. Keep your work area clear. And keep these under constant supervision. Buyer beware. Don't do this at all unless you know what you're doing, And don't do what I did. Alright, well, it's been all day. 8.5 hours, both of them are complete. So it's got them all within 1/100th of a volt, and it shows it out to the thousandths of a volt. I'm not sure how truly accurate that is, but you can see they're pretty tight. Let's see what channel B. For some reason that first cell is a wee bit short, but it's still pretty close. So that's fine. Within 100th of a volt is great. So, very happy with that. Obviously, it's done, so it's not sending any current. This just means that's how much capacity it pumped into the battery while it was doing that charging action. So, we are going to disconnect all of these wires. These are tight. Okay. I'm gonna go ahead and pull these out. Next step is to desolder these guys. Okay, get our soldering iron hot, and we're going to kind of lay it on top of each wire. And as the solder melts, we're going to pull it free. Go. There's going to be, little bitty bumps of solder left on there. That is not going to affect the ability to close this up. So we're ready now to close this up. So I'm going to grab one of the 8 amp hour covers and just put it straight down, straight on there. I mean, of course, this would be a great time to push this button. So this one, I don't have the sticker on there anymore, but this one was only charging up to 2 or 3 dots. Look at that, 4, goes all the way up. Now we just gotta put these screws back in. The long ones go in the back. The short ones go in the front. Kind of hard to do. Goodbye. We're just going to be okay with that part. All right, there we go. And there is a rehabbed battery, balanced, fully charged. And of course, if we put it in here, it's going to say that it's done, which it is. It's fully charged and ready to go. We pop it into, oh, that's a hedge trimmer. That's not what I meant to put it into. Where did the, anyways, it's ready to go. One little additional note. This particular battery, when I plugged it in, cell number 3 was at 4.15 something volts, like 4.154 volts. Because of that, this particular firmware, this particular charger, gave me an error that said it was the wrong type of battery. It thought this was a LiPo battery, and I had it set up as lithium ion. And it thought that just simply because the voltage was higher than it expected. It doesn't really want the voltage to be any higher than 4.15, and 4.10 is kind of the target for lithium ion. So the solution to that, I couldn't figure out a way to force it to continue. It just said that it was the wrong type of battery, and there was a connection error, and then it would just quit and it would go back to idle. So the solution is to unplug it. You can carefully, with these still attached, you can kind of carefully plug this into one of your higher power tools. Like I like to use the blower. the blower is, it really eats up the battery. So anyways, I just kind of like carefully plugged this into the blower without the top on it, and ran it for about a minute, and maybe a little less than that. And then when I came back, the voltage is down under 4.1, which is going to be good. So now we're going to go ahead and set this one up. I'm going to set it up to be balancing, and we're going to have a target voltage of 4.1, which is basically just charging it up while performing the balance. Go. And now it's not going to complain because all of the cells are under that 4.15 maximum threshold. You can say this one's really bad. We had one cell that was 4.1, all the rest were like 3.5, so that's way out of balance. Here we go.